Hello guys, my name is Diego Pacheco and this is another Rust video. So this is the first video in the series of two videos that are gonna cover closures in Rust. So closures are anonymous functions and I wanna show you guys how we can both return closures and receive closures by parameters. And that in functional programming is called high order functions, being capable of passing functions and receiving functions as a first class citizen. Rust is a hybrid language, it's not object oriented, it's imperative, but it has great support for functional programming. And today I want to show you guys how we can deal with closures in Rust. So first I want to show that, as you can see in my cargo.toml, I do not have dependencies, and it's a good thing, just using the standard language. So let's jump right into the closures. So in Clojure, there is, not in Clojure, sorry, in Rust, there's basically three types of traits that we have. We have fn, let me write down here, I think it will be easier for you guys to see. So there is fn, there is fn mut, and there is fn once. So these three traits, they means fn once, it means that you're going to create a closure, and this closure can only be used once. Once you use it, it's dead. It's going to be dropped, the same as you do main drop function on it, right? And it's over, you cannot use it again. fn mute, as you might guess, fn is immutable. It means that you will not mutate the value, and fn mute, it means you're going to mutate the value. And we're going to see both in these two videos. So let's start returning closures, meaning returning functions. In order to do that, I create a function here called lazy add. And the idea of this function is I'm gonna do a functional programming technique called currying, where we're gonna add a value to another in a lazy manner. So the first time we're not actually adding anything, we are just getting the base value into a function, and then when you do it again, then it's gonna be evaluated. So what we do here is we are receiving a I32. It could be any data type that Rust supports, and here is the magic, right? So you need to do impl like you would be implementing a trait, and then you're going to pass this trait fn mute, and the reason is mute is because I want to mutate the value, and the type. So this is a function. So this is just to say I'm going to return a function or a closure, anonymous function, and then I'm saying that I'm receiving an I32 and I'm returning an I32. Here could be string or star or whatever. So my code is I created a variable called code, where I'm doing anonymous function here, right? And also moving. And the reason because I'm moving is because I want to access the variable I right here, and I want to return that. So I'm moving the ownership to this function. That's why there's this move here. And then I do the code. In my code, I am creating this parameter variable, which is also mutable, called n, which is also I32. And I'm saying that n is going to be a result of n itself plus I. So we do not know the value of n on this moment, but we know that I, on this moment here on line 14, we know the value of I, right? So, but this code will not run because we are defining a function here, and here we are returning the function, we're not executing the function. That's why it's being lazy. And what this code does is printing, when this function being called, it's printing the value of I and n, and returning n, which is going to be I plus n. Then if we go to the main function, right? So I created this mutable variable closure that's gonna hold this function, this straight fn mute, and I just call my lazy add and I say 41. So here, as you can see, it returns an impl of fn mut I32 as a parameter and results are I32. So here I just having the hold a pointer to the function, I'm not really calling it. And then here I'm really calling it, but then I'm passing 1. So now it's like I'm passing this n here for this function, and then when the code is gonna run. So 41, which is I plus n1, it's gonna be 42. And here I'm printing the result, right? I also can do this currying in line like this. I can do 41 and 9. It's gonna be it's gonna be 50. And you can see that I have two parentheses here because this function here is returning a function, and then when we are doing parenthesis 9, we are calling the result of this function passing 9. And I can do this over and over. Now, let's see how we can pass function by parameters. Well, I create a simple function here called print with callback, and we're gonna pass a callback. A callback is gonna be an impel of fn. So as you can see here, I have empty parentheses, which means nothing. So this trait, it's gonna receive nothing, and it's gonna produces a string. And that's the function we need. So basically on the first line of the code, we call our callback. So we call the function we receive by parameter to get the string, and then we put some stars on the beginning of the message, concatenate with the result of the callback function, and put more stars, and we print that, right? So we're using format macro as well and print macro as well. On the main method, you can see here I'm doing print with callback, then I'm creating anonymous closure anonymous function in Rust, and then I'm just passing my code, which is okay. So okay is a stir, into a string I transform that okay into a string, and that's it. So I can run this code, and we can see that it works. So I is 41, n is 42, 42, I is 41, n is 50, 50, right? And okay. So that's it. I hope you guys like it. See you next time. Take care. Cheers.